Alright guys, welcome to this next video looking at Pythagoras theorem. And your learning goal for this one is that you use Pythagoras theorem and trigonometry to find unknown sides of right angled triangles. Now we're kind of kickstarting with this here. Now I'll be able to, at the end of this, you'll be able to use Pythagoras theorem to calculate the unknown lengths of a right angled triangle. Alright, they believed that the principles of mathematics were the principles of all things. This is something that Aristotle said in 350 BC about a group of dudes named the Pythagoreans. Okay, and they were a group of scholars and just learned people who followed in the school of Pythagoras. So he probably had a school where a bunch of people just came along and learned, thought about stuff. The Greeks were sort of all right into that kind of thing. Now, Pythagoras himself, so Pythagoras lived in about 600 BC. Okay, so nearly 2,600 years ago, so a very long time. And he's credited with the theorem we're going to look at today, but you need to know that the ideas have been around for a while. And a lot of people kind of think maybe him or his colleagues were the first people to come up with a geometric proof for why the Pythagoras theorem works. Okay. Now, some interesting things about this guy was that he was the first to call himself a philosopher, which is a Greek word of philo being lava, sophos being wisdom, so a lover of wisdom. So he's just right into knowing things and thinking about things. He heavily influenced the thinking of this other guy called Plato, who went on to sort of develop some of the ideas that sort of permeated through to the entire of Western culture, which is, you know, our culture here in Australia. And he also, a lot of people sort of think that he was maybe the first to think that the Earth was a sphere. So that's sort of a long way ahead of his time, and also that it went around the sun, which was also a very new idea at the time. Okay, so very brilliant guy, very forward thinker, and they were just totally obsessed with mathematics. So much so that they believed that all things could be described mathematically and with numbers, even so much to say as art and perfect forms and that kind of stuff, that it was all able to be analysed with numbers. Okay. So our key ideas are that in a right angled triangle, so this thing here, so we've got a right angled triangle, shown to be right angle because of that little here, the hypotenuse is the length opposite the right angle. Okay, so this length here, C, this is called the hypotenuse. Okay, so weird word, that's what it's called. Okay, now remember, capital letters mean the points. The lowercase italics mean the actual line segment itself, okay? And Pythagoras' theorem written out is that the square of the hypotenuse is equal to the sum of the squares of the other two sides, okay? Now we'll look in class at proofs for this, okay, rather than going through it in a video. But the way that we say this, and this is what you might have already seen before, is this one here. That c squared equals a squared plus b squared. So that's our idea here, is that the square of the hypotenuse, so the hypotenuse length squared, is equal to the sum of the squares of the other two sides. So here's length A, there's A squared, here's B, there's B squared, okay? You might have seen it written as A squared plus B squared equals C squared, but I'm sure you can see that's exactly the same thing. All right, how do we use this thing? Well, the main thing that we're going to be looking at with this video is being able to find our hypotenuse side. So let's say, for example, we had a right angled triangle, and Pythagoras theorem in its state here only really works, well, only does work if your triangle is a right angled triangle. So I'm going to draw one here for myself. Okay, and I'm going to give this a length of 3, a length of 4, and we need to find this hypotenuse C. Okay, now remember, obviously it can be any unknown. We're just going to put it C for now, so it sort of makes sense. All right, so we state Pythagoras theorem. So remember, when you're using these kinds of things, we need to state the formula we're about to use. So that would be C squared equals A squared plus B squared. Okay, now when you're going about this, because you've got access to a calculator, I highly recommend that you don't necessarily need to calculate everything step by step. Okay, so we're going to first substitute. So we've got A let's make this length A and this length B. Okay, and so C squared is going to be A is 3, so 3 squared plus here is 4 squared. Okay, and then to undo the squaring of this side, okay, what we do is that we take the square root of both sides. Okay, so I'm going to write that here, just so that we're taking the square root of both sides here, and we end up with, so the square root of something being squared is just it by itself. It's equal to the square root of 3 squared plus 4 squared. Okay, now, because of what kind of calculators you guys have got, I highly recommend that rather than calculating things and then writing them down and possibly making more mistakes, just type this line here into your calculator and press enter, yeah? Okay, but just for the sake of it, I'm going to show you how it kind of works. So I'm going to take the square root of 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. And you'll see that's, so C is equal to the square root of 25, which I'm sure you can agree is, therefore, C is equal to 5. Okay, now you might think, wow, that's nice and easy. Ends up the square root of a number, ends up being 5, that kind of thing. Well, this is something special, this triangle up here, called a Pythagorean triple. Okay, which means that, so 3, 4, and 5, there are other ones like it, but that's this one here, and I deliberately chose it so I wouldn't have to go running for a calculator to work out the square root of some crazy number. So there's your Pythagoras theorem. The best way to go about it is just to learn to access it by doing a bunch of problems, finding the hypotenuse length as well as the other ones as well. Okay, so that's just about learning how to rearrange the formula a bit more, and you've got plenty of the algebra experience to be able to deal with that. So thanks so much for watching, and make sure you come and see me if there were any issues that you didn't understand from part of this video. Thank you.